A warm welcome to all my friends. Today I am here to teach you the first chapter of chemistry, which is the chemical reaction and equation. So let's begin. So in this session I'll be teaching you what is the key point of it, and this session, this chapter will be divided into three parts. Then only you can identify or you can understand it very clearly. If I took it in this session itself, it will be short. So you might have not understand some parts clearly. So I am dividing this session into three parts. So this first part is nothing but about balancing a chemical equation, as we did it earlier itself. So you can click over here to see my previous video where I balanced more than 10 equations in a simple methods. Okay, so now what we need to do is nothing but this equation is already balanced. So let's come with the chemical equation. Chemical equations can be into two types, like word chemicals, okay, chemical equation in words or chemical equation in symbols. These are all are symbols. Why, if you ask, this is Mg. Mg is not element, it's a short form of magnesium. Magnesium's short form is Mg, or its symbol of magnesium is Mg. So magnesium oxide gives us 2 magnesium plus oxygen. Okay, there are types of chemical reaction also. That also I'll be teaching in this session. So here what we have is 2 MgO. So what is here, like before getting into the chapter, in this chapter you may see like reactants, products and all. So let me clearly tell you what is a reactant and a product. Okay, so reactant is nothing but like anything before the arrow. So here where is the arrow pointing this side, right? So anything with the arrow where it's pointing, that's nothing but the product. Okay, and before the arrow where this starting point is there, no, there will be our reactant. Okay, and this is 2 form. Okay, that arrow is called 2 form. So reactant, okay, to form product. That's it. So reactant to form product. So where is the reactant over here? Reactant is nothing but MgO. And what is the product over here? Mg to Mg plus O2. If you closely look over here, they both are balanced itself. So if you don't know how to balance, I'll just give you a short thing. So 2 MgO. So this 2 will multiply the both, where they have 2 magnesiums are there, 2 oxygen are here. But this side also 2 magnesium are there and 2 oxygen are there. So suppose if there is no 2 over here, what we need to do? We need to add 2 to make them both balanced. That's how to balance a chemical equation. The reactant and the product side should be balanced. So now we checked how to balance a chemical equation in short, and we know what is a reactant and a product. Now let's define it. So here now let's discuss what is a chemical reaction. Chemical reaction in the sense, as in last example we took magnesium oxides gives us magnesium and oxygen. Okay, now what we'll do, we'll just magnesium plus oxygen gives us magnesium oxide, right? Nothing, just same, we are just reversing the chemical equation which we took at the last. So here we have some observations that takes place when a chemical reaction has taken place. So the observation that tells a chemical reaction. So suppose there's a chemical reaction taking place over there. So these observations tells us that. So we don't know what the chemical reaction is taking place or not. But by observing it, we can conclude that like this, if there is any of these, that means there is a chemical reaction taking place inside that. So for example, change in state. Change in state in the sense like from one state to another state it's changing. Example like solid to liquid or liquid to gas or solid to gas or gas to solid. Okay, solid to gas or gas to solid. Gas to solid, for example, I'll give you CO2. Okay, it's carbon dioxide into dry ice. Dry ice, you know, right, nothing but CO2 in a compressed form, and they'll just liquefy it and leave the other impurities, and they'll form a liquid. Oxygen is also there. From gas to liquid also is there. So here we next one is change in color. Change in color, for example, copper sulfate or copper or iron, like when they come direct contact with oxygen, they change their color in the form of like rust, like brownish color, right? So like in the form of rust we can tell, like when the copper or when a metal is shining, like when oxygen presents, like example, if for railway station, railway tracks and all, if you see, the steel will get rusted or the steel which is available near our earth, that most of them will get easily rusted, right, when they come direct contact with oxygen. So third one is change in temperature. Change in temperature in the sense the temperatures decrease or increase. For example, this liquid oxygen is there, right? So when we keep them, that is in minus degrees, right? So when we come contact with some other degree, it forms into like elephant toothpaste. It from normal temperature it rises very high. So the last one is evolution of gas. Evolution of gas, zinc plus sulfuric acid gives us zinc sulfate plus hydrogen gas. So hydrogen gas is evolving from it. Example is what I told for it is zinc plus H2SO4 gives us zinc sulfate plus H2. Okay, this is the reaction taking place. Here the hydrogen is a gas, right? So that is evolving. Hydrogen is evolving. So how to find whether the hydrogen is evolving over here? There's a method to find that also. Let's see. So here we have some types of chemical equation. As I told in the previous, there are some types of chemical equation, right? So these are they. So A plus B is equal to A and B. This is called a combination method. Combination equation. So suppose if I'm having an element A, okay, and the element B, so they combine to form AB like this, okay. So next one is AB. So there's two elements which gives us they separated due to some electrolysis, some methods that I'll be teaching in the next session, okay. So this session I'll be teaching the types of equation, and let's find it using some equations. I'll give some chemical equation and let's find it together what type of equation it is. So here we have this decomposition equation. So decomposition equation is nothing but, so there's two equations, there is two elements. For example, magnesium oxide is there if you see. Okay, so that two magnesium oxide, when I heat them or electrolyze them or even dose them to the sunlight, so they get separated to magnesium and oxygen. Okay, so next one is AB plus C gives me AC plus B. Okay, AC plus B. So what here, it is displacing that C is displacing the B over here. So over here there is already one A and B is over here. Okay, so they are like magnesium oxide for example I'm taking. But here there's another equation. Okay, there's another element coming over here, join them. So this C is coming in the place of B. Suppose I'm over here, okay, I'm over here and I'm with my friend. So he brought his friend. So what happens, my friend, okay, I went to his friend and my friend is alone now. Okay, that's the equation. So next one is AB plus C and D, okay, plus C and D. So over here, C and D gives us AC plus BD. Okay, so here what is happening is, like I and my friend is coming and another two guys are coming, okay, another two pair are coming. So what we are doing is we are exchanging our friends. So for example, I and my sister is there, I and my brother is there, and my friends and his brother is there. So I am going with his brother and my brother is going with him. Okay, that's here, this is the chemical equation. So this chemical equation is called double displacement. So double displacement in the sense, there are two oxygen or two elements, they're displacing it. Here this is single displacement because one element is displacing only one element over here. But here two elements are getting reversed or they're multiplying crossways, like A into C and B into D. Here what happened, they both are only getting multiplied and this A is staying there itself like alone. Okay, so this B is getting displaced over there. Displaced in the sense the reactivity series, that also I will be teaching in the next session. Okay, so now let's see some equations or chemical equations to find what type of equation. So as we have come to the end of our session, so let's find which chemical equation. So this chemical equation, let's find what type of equation are they. So the first one is N2 plus 3H2 gives us 2NH3, and the second one is 8SO3 gives us S8 plus 12O2. Then zinc plus hydrochloric acid gives us zinc chloride plus hydrogen, and aluminum bromide plus potassium sulfate gives us potassium bromide plus aluminum sulfate. So first one is N2. So A plus B gives us AB. So what type of equation it is? Nothing but sublimation or synthesis. So the second one is AB gives us A and plus B. So it is nothing but decomposition. So the third one is zinc plus 2HCl. So A plus BC or AB plus C gives us AB plus C. So what type of it is? It is displacing. What it is displacing? The zinc is displacing the hydrogen over here. So it can be either HCl plus Zn also, or Zn plus HCl. Okay. So it's displacing this hydrogen over here. Okay. Next one is AlBr. So AB plus CD gives us AC plus BD. So what type of equation it is? Nothing but double displacement. So I hope you understand what are the types of chemical equation, how to find, or what are the observation to clarify that the chemical equation has taken place. So see you in the next session.